Okay, now we're going to be doing 7.4 here, which is adding and subtracting radicals. Oops, sorry about that. Adding and subtracting radicals. All right, so adding and subtracting radicals is a lot like adding and subtracting like terms. The radical has to be exactly the same in order for us to be able to add and subtract them. The radical, meaning the index and also what's inside, okay? That has to be exactly the same in order for us to be able to add them together. If we identify that they are the same, such as the square root of 5, let's say I have 2 square roots of 5 and I'm adding 4 square roots of 5. This is very similar to 2x plus 4x. That would be 6x. So I'm going to do the same thing with my radical. I've got 2 square roots of 5 and I'm adding 4 square roots of 5. Or just 6 square roots of 5. So we just take what is on the outside, similar to the coefficient of like terms, and add them. Cubed root of x plus 5 cubed root of x. So they're both cubed root of x. When there's nothing in front, we know that that is 1. 1 cubed root of x plus 5 cubed roots of x. 6 cubed roots of x. So the radical simply stays the same, just like up here. Okay, so the index has to be the same and what's underneath the radical has to be the same. Now, sometimes it takes some simplifying. Let's say I have 4 square roots of 32 minus 2 square roots of 8. Well, square roots of 32 and square roots of 8 are not the same radical, but they both can be simplified. So we'll do that first and see what we get. 32 is 16 times 2. So I'm looking at 4 times the square root of 16 times the square root of 2. 4 times 4, because this right here is another 4, times the square root of 2. So this simplifies to 16 square roots of 2. That 4 is a multiple, 4 times the square root of 32. So when I simplify the square root of 32 into the 16 times the 2, the square root of 16 is 4, so I have to multiply that by that 4. Sorry, getting a little sloppy here. So 4 times 4 times the square root of 2. So let's do this over here. So this 2 times, and the 8, we'll split that up into 4 times 2. 2 times the square root of 4 times the square root of 2. So that's 2 times 2 square roots of 2, or 4 square roots of 2. So this problem is 16 square roots of 2 minus 4 square roots of 2, which is 12 square roots of 2. So if they're not the same radical, you ask, can they be simplified? And then what do we get once we simplify them? Let's look at some more examples. All right. square root of 18k minus the square root of 72k. So again, I'm going to simplify each of these radicals. The 18 is 9 times 2. The k is not a perfect square. So 2 is not a perfect square, k is not a perfect square, but 9 is. So this square root of 9 is 3. The 2 and the k stay underneath the radical. The 72 is 9 times 8. But 8 has a perfect square of 36 times 2. 36 times 2 times k. So the 36 is my perfect square, and that'll be 6, and the 2k stays underneath the radical. Don't forget what we're doing. We're subtracting. So now I do have like radicals. Square root of 2k, square root of 2k. So 3 minus 6 will give me a negative 3 square roots of 2k. And that's my simplified answer there. All right, one more example for this section. It's a short section. Let's say we have a different root other than square root. Let's have 5 fourth roots of a to the 5th power b cubed. And I am adding the 4th root of 81 a b to the 7th. So they're not like radicals. They're both 4th roots, but underneath the radical is not the same. So I need to simplify. Can I simplify? This one, the a to the 5th, that can be written a to the 4th times a, and then my b cubed cannot be simplified if that is smaller than my index. So this is all multiplying a 5. So where's my perfect square, or not square, sorry, my perfect 4th root is right here. The 4th root of a to the 4th is a. So this is 5a, that's underneath the radical still. So it's the 4th root of a b cubed. So 5a times the 4th root of ab cubed. That's that one. Now over here, is 81 a perfect 4th root? It is. It's 3 to the 4th power. You could find that out by doing prime factorization. 9 times 9, 3 times 3, 3 times 3. So you see you got your 4 factors that are all 3s. So 3 to the 4th power, it's a perfect 4th power. The single a, nothing I can do with that, but the b, I'm going to write that as b to the 4th times b cubed. Because it's a 4th root, I want to go down to the first multiple of 4, which is just a 4. So I have to write this as b to the 4th times b cubed. So now, there's nothing multiplying this out in front, just a 1 factor. So where are my perfect 4th roots? The 4th root of 3 to the 4th power is 3. The 4th root of b to the 4th power is b. So the a and the b cubed are left underneath the radical, a b cubed. Don't forget what you're doing. We're adding them. So now look, I have the same radical, the 4th root of ab cubed. So that means I can add the 5a and the 3b, but they are not like terms. So they have to just be written like that. I can't combine 5a and 3b. They are not like terms. So we simply leave it 5a plus 3b, and that has to be in parentheses, and then times 4th root of ab cubed. Think about it. If I took this and distribute it to both of those, I would get that. So that has to be in parentheses right there. So not only do we have to look out for the like radicals in order to add them, but what is out in front also has to be like terms in order to add them. Here we didn't get like terms, so we just leave it 5a plus 3b times the 4th root of ab cubed. Okay, that's it for this section. See you after spring break.